Good morning students. In today video lecture, so we're going to study about the pneumatic control systems. Okay. So already you gone through the similar kind of control systems in the hydraulic part. So as you know that you can go with the hydraulic system or pneumatic system. There are basically three types of control system, that is DCV, FCV and PCV, means direction control valve, pressure control valve and flow control valve. These are three very important control systems as well in a pneumatic system as well as in the hydraulic system. So first you just go through the brief classification of this different valves in the hydraulic this is pneumatic system. So if you come to the flow control valves, so in the flow control valves, that is a non-compensated flow control valve. Okay, so then temperature compensation divider. So and same thing in the direction control valve, there is a poppet valve, spool valve, and next pressure valves, and last fourth one is a non-return valves. Under the non-return valve there is a check valve, settle valve and quick exhaust valve. Okay, so this is about the brief classification of valves. And then if you come to the functions of these valves, okay, so what are the importance of these valves you can know first. So that is first if you come to the direction control valve. Okay, so because in the hydraulic or pneumatic system these are very important, play a very important role, these all three types of control systems. Under the first direction control valve, control valves will control the directions of the fluid flow in the system, that is air flow in the pneumatic system, that is direct the flow of fluid, that is extension and retraction stroke, desired actuator. Okay, control volume, speed control, and pressure control values is limit maximum system pressure and regulate the force or torque and actuator generates. And need of flow control valves. Okay, so it is essential to ensure efficient or reliable and safe operation of the pump system. And this kinetic energy absorbed as a pressure is carried in the fluid and slowly lost to friction in the piping system. Controlled fluid in motion can physically destroy the pump or piping, valves, meters and other system components. So the factors which are affecting the flow rates, that is the cross-sectional area of the orifice, shape of the orifice, that is round, square or triangular type, length of the restriction, pressure difference across the orifice and viscosity of the fluid. These are the factors which affects on the flow rate of the fluid. Okay, so first you discuss about the direction control valve. Under the direction control valve there are two types, there is the poppet type and the spool type, DCV. Okay, so the DCV valve performs three functions, that is first one, stop the flow rate, fluid flow, allow the fluid flow and change the direction of the fluid flow. These are the mainly three functions. These three functions will be executed by this DC valves, any DC valves, either it may be a spool type or a poppet type. Okay, so it may be restrict, or you can stop the flow of fluid in the system, or allow the flow of fluid in the system, or you can change the direction of the fluid. So these are the main three functions are executed by the DC valves. So we'll discuss about the valve classifications. So valves can commonly classified in different ways, that is you just gone through the symbolic representation of the different classification of the valves. So that is the first one I will explain, is a 2-port and 2-position DC valve. Okay, so whatever this first figure is indicating, it is a 2-port and 2-position. So what is a 2-port and 2-position means? So in this valve, whatever this symbol is there, so it is, this is one port and this is one port. So that's why it is having it, or it is consisting of two valves. And 2-position. 2-position means what? There is a two rectangle box here. So one rectangle box is one position, and second one rectangle box is a one more position. So that's why you can call it, this is a 2-port 2x2 valve, means 2-port 2-position valves. Okay, so 2x2 DC valve it is. Okay, and similarly if you come to the second sketch, or these are the symbolic representation of the valves. Okay, so here it is of 3x2. 3 means what? The first number indicates is the number of ports. Okay, and second number indicates the number of positions. So here the positions are 2 because it is having the 2 rectangle box. One first rectangle box is one position and second rectangle part is another position. Okay, so it is a 2 position. 3 ports. 3 ports means what? This is one port and this is one port and this is one port. Okay, there are 3 ports. That's why it is called in 3/2 DC valve. And next, if you come to the second, that is third sketch of the symbolic representation, it is a 4/2 valve because the position is again 2 only, but the valve are increased because there are 4 valves. So this is one valve and this is one and this is one and this fourth one. Okay, it is consisting of totally 4 ports and 2 position. So that's why I can call it as an 4/2 valves. Okay, so last one is 4/3 position. Okay, so it is having the 3 position because just go through this. So it is having the 3 rectangle box. This is first one is the rectangle box, third one is second one is the rectangle box, and third one, because each rectangle box indicates one position. So that's why it is consisting of 3 position. And number of ports, you can go through the each position, it is consisting of 4 ports. Okay, so that's why it is a 4/3 DC valve. Okay, so this is one port, second port, third port, fourth port. Okay, so by operating this DC valve, you can push or you can change the position of the valve. Okay, so because this middle position, later in the coming stage I will explain. So how, what is this middle position or this condition or this condition. So as of now you can just understand how you are going to represent the valves in a symbolic way. Okay, so that is 2/2, 3/2, 4/2 or 4/3 valve. Okay, so next, method of actuation of DC valves, because you know the DC valve functions of DC valve, it will control the flow rate or you can stop the flow rate. Okay, or you can change the direction of the flow of air in the system. But how you going to actuate those valves? Okay, so again you going to use the different methods to actuate the valves. This all are symbolic representations. So you just go through this. First one is the push button type operated or the actuated. So this is symbolic representation of that manually or the push button type actuation of the DC valve. Okay, so the operating person can push this button and he can change the position of the valve. Okay, so this is first type. And second one is the lever operated. Again you can manually change the lever position and similarly automatically that position of the valve will get changed. And third one is the pedal operated. Okay, and next one is the plunger operated. So these all are symbolic representation. It is the plunger and the spring operated. Here there is the pneumatic or the pilot operated, solenoid operated, and the combined air and solenoid operated. So these are the symbolic representation of the actuation of this DC valves. So next you come to one by one how this 2/2 DC valve or 2/3 DC valve will operate, working principles you can study. So this schematic representation, it shows the 2/2 direction control valve, that is a spool type. Spool means what? This rectangle piston type, whatever the part is there, it is called as a spool. Okay, so that's why you can call this as a spool type DC valve. 2/2 means it is consisting of 2 positions and 2 ports. Here are the 2 ports. This is a, the alphabet A indicate this is one port, and the first port is a P port, that is a pressure port, and this is a working port. A means working port. Okay, and there is a rod is there, piston rod, and there are 2 spools are there. Okay, and it is a spring returned. Okay, it is a cylinder or the body of the valve. Okay, so P indicates means pressure port, means through this port the pressurized air will get entered into the valve. Okay, then that pressure will act on the spool, then the spool will change the position, and these spools will control, means cover and uncover the valves. So it will control the direction of the fluid. So as of now the pressure port P is open now, and this working port A is covered because they will not allowing the air to flow from P to A port. Okay, it is covered position. This is the first position and this is the second position. Okay, so in the first position, what is happening? Through the pressure port, the compressed air or the high pressure air will get entered into the DCV. But as the pressure, high pressure will get built on the spool, then automatically the spool will get moved and the spring will get compressed. So okay, then once this spool, first spool will uncover the port A, then automatically this pressurized air will go from pressure port to the working port. Okay, this is in the first position. In the first position, the air only entered into the DC valve. Okay, it is not going through the working port. And if you come to the second position, see here in the second position, both the ports are open. The pressure port is also open and the working port A is also open. So what is this meaning is, the air which is coming from the actuator, that is from the cylinder, compressed air or the high pressure air, so that will go through the working port. Okay, means after the DC valve there is a actuator that will go through the inlet of the actuator through port A. Okay, so it is a supplying of air from pressure port to the working port. But in the first position, it is not open. Okay, this spool is covered with the working port, so that's why here the air will get restricted, the flow of air is get restricted or the stopped, but here it is allowing the flow of air from pressure port to the working port. Okay, this is how, that's why here showing that, see, just go to the symbolic representation here. Pressure port means air is not flowing from pressure port to the working port, but in the second position the air is flowing from pressure port to the working port. So okay, on position it is actuated, off position, normal position it is. Okay, so this is about the 2/2 direction control valve. So similarly, if you come to the 3/2 DC valve, 3 means the number 3 indicates number of ports, first number, and second number is the number of positions. So first you can identify the 3 ports here. First port is the pressure port, and second port is the working port A, and third port is the return port R. Yes, here there are 3 ports and it is a 2 position. Okay, so this first symbol or the first sketch is indicates one's position, and the second sketch indicates the second position. Okay, so in the first position, so how this where the spool are there, so just see there, the pressure port is open, return port is open, and this working port is open. But thing is that you just go through the different components of these ports. Okay, it is consisting of the body and there is a spring. Okay, one end of the spool is supported with the spring. Okay, all body, and there is a push button type, just here. So in previously just you are discussing about how you going to actuate. So the operating person will push this button and he change the position of the valve. So how this valve will get work. Okay, so in the first position, if you want to understand that, so the pressure, all ports are open, but here you can understand that the air is coming from working port to the return port. Okay, because here the spool is uncovered with the actuator, that is the working port and the return port. Okay, is covered with the pressure port. So just see this actuated position is P to A, and A is a closed. Okay, and in this position P is closed. The working, that is initial position is A to R. So this is a symbolic representation of the this is a symbolic representation of the 3/2 position valve. See here clearly I am indicating the different valves. That is pressure port. Okay, this is a working port A, and this is a return port. So in the first position, this is the first position, that is the initial position, this sketch is. Okay, in this figure what is happening, so that compressed air or the high pressure air is flowing from pressure port to the working port. In the symbol also you can see symbol, that is with the arrow direction I am indicating, showing here from pressure port to the working port. The air is flowing from pressure port to the working port A, and through this port it is going through the actuator. Okay, so here it is actuator, so that will execute the working stroke. and if you push the button, then the valve will change the position. It will come to the second position. In the second position, see the direction of arrow. So it is connected from A to R. So you can just observe the sketch, second sketch, this sketch. Okay, so here in this sketch, the valves A to R are get connected. So means the air from the working port A and is going return back to the reservoir. That is a return. R means it is a return port. So through return port, the air will goes to the atmosphere. You can leave it to the atmosphere. Okay, in case of hydraulic system, you can supply it to the reservoir. Okay, so this is how this 3/2 direction control valve will get work. So and similarly it is a 4/2 direction control valve. Okay, so 4 bar means what? There are 4 ports here. Just see here, just I will first explain you the symbolic representation of this 4/2 valve. The positions are 2 here, first rectangle and second rectangle, and it is a push button type operated, and it is 4 ports are pressure port. P means pressure port, A, B means it is a working ports. Okay, A is also one working port, B is also one working port, and R is a return port. So in the first position, so what is the how the valve is connecting? In the first position, the pressure port is connected to the working port A. At the same time, the working port B is connected with the return stroke. That is a return valve. Okay, so you can go through this per sketch. You can come to know that. Again, it is having the body that sketch wise or the symbolic that is construction wise. These valves are similar. It is having the spool and is a spring return valve. Okay, and you can mount it with any. You can operate this with the push button type or any solenoid valve like that. So, but here you can just go through the ports. It is a pressure port and working port A, and is a return port and working port B. So here in the first position, I am just explaining you about this first position. In the first position, pressure port is connected with A, and the working port B is connected with the return port. Okay, just see similar way. This pressure port is connected because they are uncovered by the spool. That's why the pressure air is flowing from pressure port to the working port A. At the same time, the non-pressure fluid which is there in the actuator, so that will returning from the working port B to the return port. Okay, so that is how from pressure air is going from P to A and non-pressure air is coming from B to R. It is the first position. If you change the position of the valve, then that if you come to the second port is a cross. Just check out here, there is a cross connection with this cross arrows are there. B pressure port is connected with B. Okay, and the port A is connected with the return port. Means in the next position, the high pressure air is flowing from pressure port to the working port B and reverse. Okay, and the low pressure air is which is there in the working port A, that is going back to the return port. Okay, so that is how, see, just see this here. So A port is connected with the return port, and the pressure port is connected with the B port. Okay, so this is what the 4/2 DC valve. And next 4/3 DC valve is there. It is just symbolic representation. There are 3 positions here. This is the first position, second position, and third position. This middle position is there, right? It is a neutral position. You can call it here I am explaining it. Just see red color. First position is a closed center position valve, and second open center position valve, and tandem center position valve. Okay, so it is a neutral is the second and third, and closed just symbolic representation of all 3 cases, that is closed center position, open center position, and tandem center position valves. Okay, and similarly you can go into study about some non-return valves. Okay, first under that again you gone through studied in the hydraulic also, in hydraulic systems while studying about the hydraulic valves. So similarly check valve, this is a basic valve which is used in the pneumatic or hydraulic system. These valves are called as a non-return valves. Okay, so these valves allow the fluid to flow in only one direction. Okay, so this is first one is the check valve. It is a symbolic or the sketch wise explanation. It is a spring, low tension spring, and there is a no flow valve and no flow direction. pre-flow. And in this hydraulic, or especially in this subject, the symbolic representations are very important, because if you go through the construction sketch wise, is very complications, means very complicated sketches are there. So better you can go with the symbolic representation. Okay, this is the first type, is a non-written, that is a check valve. Is a check valve symbolic representation here. Even I am showing these two with the arrow indication. So this indication is pre-flow. So the air will flow from this direction, it will not flow from in opposite direction. Okay. So if the pre-flow, if the pressure air will come through this port, and it will push this spring above, and the air will flow from this position to this, but at the same time the air will not come back, okay, in the same direction. So that's why it is called a check valve or the non-return valve. Similarly, it is also shuttle valve. Okay, there are three ports here, that is X port, L port, and Y port. This shuttle valve will allow the flow of air from Y to L. Okay, so that is why how it is a symbolic representation. And next, a quick exhaust valve. Okay, with a small pressure difference, the valve will get actuated. The see here in the first position is the construction, the flow of air from pressure port to the L port. Okay, so in the first sketch, and in the second sketch, the air is flowing from L to R, means return stroke, a working port to the return reservoir. It is flowing. How this quick exhaust valve will get work. So thank you.